Hi everyone, this is Hardik from fuzzing.in. Thank you for watching my videos. In today's video, we are going to see what is the latest OpenSSL vulnerability, how can we replicate this vulnerability using the test cases which are provided by OpenSSL, and then we will see how can we find this vulnerability using libfuzzer. So let's start. As you all might be aware that this vulnerabilities created a lot of hype, and initially it was claimed that these vulnerabilities are critical, but later on while the patch was released it was marked as high severity. So there are actually two vulnerabilities which got fixed, and we will go through the official OpenSSL security advisory which has been released on 1st of November, like 2-3 days back only. So the first vulnerability is CVE-2022-3602, and this is a 4-byte buffer overflow while parsing some certificate fields, and the severity for this is high. And the second vulnerability is CVE-2022-3786, and this is a email address variable length buffer overflow which can be triggered by parsing a typically crafted certificate which has a name constant field inside that. So these two are the vulnerabilities, and I think one of them was discovered by Polar Bear, and the second vulnerability is discovered by Victor Dukhovny, and the official version in which this vulnerability was fixed is 3.0.7, and the vulnerable version was from 3.00 to 3.0.6. So what we are going to see first is that we are going to look at the function, what are the function which has been fixed for this vulnerability, and then we will see how can we replicate this issue using the test cases which are provided with the fixed version, that is OpenSSL version 3.07, where this vulnerability was fixed. So how can we use those test cases on a vulnerable version, that is 3.0.6, to replicate this vulnerability at our end, and might be if you want to do some debugging, then you can use this technique. So let us go ahead and look at the official patches first, and then we will see how can we replicate this vulnerability. So if we go to OpenSSL GitHub, and if we select the version or branch as 3.0.7 over here, we can see the code for that. So in the commits, if we go, that there are two fixes actually, that is CVE-2022-3602 and CVE-2022-3786. So let us go ahead and see this commit first, and we will figure out what has been fixed. So you can notice that there is a very simple check which has been added over here, like there is a return out greater than max out, which was in vulnerable version, but in the fixed version one check which is equal to has been added over here, that is return out variable is greater than or equal to max out. So this will prevent the vulnerability, this will prevent the CVE 2022-3602. and the second fix is over here in this commit. If we go and check, there are some size rated checks has been added over here, and this function has been added, push C. So if we go and check, so you can see that there is a new macro has been defined over here, that is push C, and this push C macro, what it does is that there is a do while loop where it basically makes sure that the size variable is less than the max size, and if the the value of size variable is more than max size, then it sets the value result as 0. So this is the thing, and then you can notice that there was one mem copy over here, but it has been replaced by this push C macro over here, and yeah, so these are the changes in that. And you will also notice that this particular vulnerability is in the function OSSL underscore A to U label function. So this is where this second vulnerability CVE 2022-3786 was present, and the first vulnerability is present inside the function OSSL underscore punny code underscore decode function. So this is the function where this first vulnerability was present. Now that we have understood the function which are responsible for this vulnerability. Now let us go ahead and see how can we actually replicate this vulnerability by using the test cases which comes with OpenSSL. So we need to do git clone. So for that we will use a command git clone and then URL for OpenSSL git repo. So in my case, I already cloned this repo, so it's already present on my system. That's why I'm getting this error, that is fatal error. And now what we can do is that we can go to this particular directory and then we can check out the fixed version. So first we will look at the test case, and for that we need to use the version 3.0.7 because this is the version where this vulnerability was fixed. So I have simply used this command, that is git checkout OpenSSL particular version. Now we will go to the test folder and we'll see that there are a lot of test cases over here. So the one which we are interested in is something called funny code. So let's do one thing. We'll simply do a grab if there is any funny code over here. So yeah, there are few test cases which has been added over here, and we can see there is one file, that is funnycode_test.c. So let us open and see what happens inside this file. So you can notice that this is calling like some header over here, and then there are some test cases. So this is the first one, that is funny_test, and then there are a couple of cases like Egyptian, Arabic, Chinese, Czech, Hebrew, Hindi, Japanese, Korean, etc. So these are the some characters which are part of this particular array, and then there is a function like which is test_funnycode. So you will notice that this function is responsible for testing one of the vulnerability, one of the test case for the vulnerability, and the second one is responsible for the second vulnerability. So what we are going to see over here is that test_funnycode function, you will see that there is a test string over here, that is funny_test. There is a buffer which is of size 50 bytes, and there is a buffer size which is like the size of this particular buffer, and this is a test case. So you will notice that this is where this vulnerable function is being called, that is OSSL funny_code_decode, and the parameter are being passed over here, that is tc dash encode it, and the length of this particular string, and then there is a buffer, so which is the output buffer, and there is a size of this buffer over here. So let us go ahead and actually open this function, and we'll see what happens in this function, and then we will come to this test case. So let's open this file and look for that particular function. So the file name is funnycode.c, and it is present inside crypto directory. So okay, here we can see this function. It starts at line 118, and so here is a function which is vulnerable, and we can see that it expects few parameters. So first one is p encoded, that is some pointer, and then there is length, then there is decoded buffer, and there is a length of decoded buffer. So these are the four parameters, and you will see that there is some processing which happens over here, and if we recall, the fix is over here, like return out. Previously in vulnerable function, return out was greater than max out, but in this version it has been fixed as return out is greater than or equal to max out. And then you will notice that there is a memo call over here, which where some data is being copied to the decoded buffer over here. So we will not go into much detail over here, and now we will go to the test funnycode.c. So the same parameter, like as we see, there are four parameters which are being passed over here, and then it is comparing the memory if it is equal or not. If it is not equal, it means that there is some issue, and so this test case will fail. So this is the first test case, and the second one is actually over here, paste funny overrun. So you will notice that again the same function like OSSL decode underscore decode is being called over here, then with the parameter, and then there are some memory compare operation is happening over here, and this string is being passed over here. So this is the second test case which we are going to use, and if this test fails, then it will say critical buffer overrun detected over here. So the first test case is this one, A2U label, and the second one is the test underscore funny underscore overrun. So now what we can do is that we can probably go ahead and see how to compile this test case, and then we will try to replicate this on the patched version first, and then we will see it on the unpatched version. So we need to create a debug build that will actually help us in identifying the location of the code. So it's pretty straightforward. In case of OpenSSL, we can simply run configure command, and we can use a option that is dash prefix, and we can give the path something like our current directory where we have jet clone the OpenSSL, and we can create a new directory called build. So what it will do is that when we will do make install, it will install all the binaries inside the build folder. So this is very useful while replicating some vulnerabilities, so you can have multiple version of different software or SIEM software installed on different locations. So I generally use that, and then we also need to use cflags. So we will use, what we can do is that we can export cflags first, like we will use debug build. So we'll use gdb and -0, it means no optimization, and we'll use address sanitizer and undefined behavior sanitizer. So we have exported this, and now we can simply run our configure command over here. Actually I have given wrong path, so it should be OpenSSL underscore work OpenSSL, and then so now what it will do is that it will generate makefile, and then we will compile, and then we will install, and then we will run the test cases. So it will take some time. I'm going to pause the video. When it will get finished, I will start it again. So it is installing, and it will take few more seconds, so let's wait. We can actually disable the documentation because in this case we may not be needing that, but anyway. Okay, so the installation has been finished, and if we go to build directory, you will see that it has the OpenSSL binary over here. So that is fine, and it is working. So if we go to the test folder now, and if we simply run funny code test, right, you will see that there is a compiled binary. So it runs all the test cases like test funny code, test A2U label, and test funny overrun. But what we can do is that we can simply check if it has any help section over here. So you can see that it has different options. So let us list out all the test cases. So basically there are 3 test cases. Test 1 which checks for funny code. There are different domains, as we have seen. There are different characters. We'll test for them. Plus test 2 is for the A2 label function, and test 3 is for the overrun CVE. So what we can do is that we can test individually, and we will check second one. So here it is getting passed. It means that that vulnerability is not present over here. Similarly, if we do test 3, it means that it is working fine. The status is okay, so it is working perfectly fine. Now if you recall, this is the version 3.0.7 where this vulnerability was actually fixed. But what we need to do is that we need to try this on the vulnerable function, and the vulnerable function is 3.0.6. So what we will do again over here is that we will do a jet clone just to avoid any issue, and we will clone it into a separate folder, like say OpenSSL vulnerable. So once it finished the cloning, we will go there, we will copy the taste from 3.0.7 to this vulnerable function, and then we will see how does it work. It will take few seconds, so we need to wait. Okay, it's done. So now we will go to this vulnerable directory, and then we will check out the vulnerable version, that is 3.0.6. So the command is git checkout OpenSSL-3.0.6, and you will see that it contains the vulnerable function over here, and we can verify it. So if we go to the crypto and punycode.c, and if we look at that particular function, which was OSSL punny_decode, and if we go to that particular line, I think it is somewhere around 185 over here. So you will notice that this check is return out is greater than max out, so that equal to sign is not over here. It means that this is vulnerable. So now what we can do is that we will go to our fixed version, that is OpenSSL. Okay, and we will simply copy our paste to OpenSSL over OpenSSL underscore vulnerable paste over here. So what it will do is that it will copy all the test cases from the fixed version to our vulnerable OpenSSL version. And now we can actually go to vulnerable version, and if we go to the test directory, and if you open punycode paste.c, you can see that this file is present over here. So we can simply make this is it configured. So we need to use vulnerable and then build. So what we are doing is that we copied our test case from the fixed version to the vulnerable version, and then we are building the OpenSSL so that it will create all the test case. It will create executable file for all the test cases with the vulnerable installation, and then we will run those test cases. So the config is successful. We can simply do make create and make install. It will again take few seconds, so I'm going to stop this and I will start it again once the installation is finished. Okay, so the installation has been successful, and if we go to the test folder or test directory now, and if we run the punycode test, right, so you will see that we are getting a address sanitizer error message over here, which is a deadly signal over here. And you can notice the call stack, so it is inside OSSL A2U label function, which is over here. So if we check crypto punycode.c and we go to line 303, so if we go to line 303, you can notice that this pointer, there is some data, some dot is getting saved in this particular pointer location. So looks like some overflow over here. So this is the thing. But now, as what we can do is that we can actually run various test cases. So let us run one by one. So we'll run first test. So first test is getting passed. If we run second one, this is where the address sanitizer is kicking in, and if we run third test, we can notice that it's a buffer overrun which has been detected over here. So it means that these two vulnerabilities we can easily reproduce or replicate using the provided test case. And if you want to debug, you can simply use GDB. You can use punycode.test file, and then you can give the required parameter, that is test1 over here. So you will notice that okay, I think we need to give test2. So you will notice that our pondbg has been kicked in over here, and we can see the line, the source code over here where this program is crashing, and we can see the function and everything. You can see it over here. You can debug it using GDB. You can put some breakpoint, and you can continue debugging that. So I'm not going into much debugging for this issue right now, because my idea was to show you how to use the existing test cases in OpenSSL and replicate the different vulnerabilities. So I think this is helpful. And now one more thing we can do is that we can see like how can we fuzz this particular function using libfuzzer. So how can we find this vulnerability, how much time it will take. So interestingly, there was one Twitter post where the authors mentioned that this vulnerability can be found within few seconds, I think less than a second, and the harness was already provided over there. So I need to create one C file, and even I was able to get this crash in less than a second. So let us see how we can use libfuzzer to find this particular vulnerability. So this is the actual post, and it has been from a username called Hanno, H-A-N-N-O, and he posted this tweet saying that this bug can be found using libfuzzer, and the harness is also given over here. So if we use this harness, we can try replicating this issue, and we'll see if we are able to find this issue or not. So let's simply use this harness and see if we are successful or not. So here is the harness function which I have written, and this is for libfuzzer. So if you are following my video, you will notice that in libfuzzer harness we need to use a specific function, that is llvm fuzzer takes one input, and it is a standard format. So it expects a data which saves all the mutated data, and it has one size which is size of the data, which is of this buffer. So, and inside that we have taken two variable, that is bar, which is of 32 bytes, and this is like size of this particular buffer, that is 32 bytes. If you recall the test cases which we have seen, and then we are simply calling this function. This is a vulnerable function, that is OSSL underscore funny code underscore decode, and we are giving this data size, and followed by this two other like output parameter, right? So it will decode and it will try to store it over here and then return 0. And we don't need main function. So let's compile this using clang. So we can compile this harness program using this command, that is clang -app sanitize is equal to fuzzer. Fuzzer we need to add because we are going to use libfuzzer. So this is built in using in clang. Then address and undefined are the sanitizer which we are going to use. Then this is our source file. -o is our executable file name, and then we are linking with libcrypto and libssl. So I need to use this path because there was some issue with the command, like when I was using lssl and libcrypto, it was not working for some reason. So I decided to use this to file path, and when we compile this program, it gives us a executable file, that is first funny code decode. And now let's run it. So when we run it, what will happen is that libfuzzer will provide some mutated data, and it will try to call this vulnerable function, that is funny code underscore decode, and then let's see what happens and how much time it takes. So you will notice that as soon as I hit enter, it crashes. We get one crash, and we try to see. So you can notice that it is a stack buffer overflow over here, and if you see the line, so it is inside crypto funnycode.c8 line 187 over here, and yes. So if we open this file and we go to line 187, you can see that there is a memo call. This is where the vulnerability is, and before that you can see that it is This is the vulnerable condition. So it is not returning, it is coming over here, and data has been copied to this buffer, and that's where our program is crashing. So you will notice that it did not took like more than a second to find this crash, and this is the beauty of fuzzing. So somehow this check was missed because this was a new code. So let me once again open the fuzz harness, and you will notice that we are using only single function, that is OSSL underscore funny code underscore decode. But what you can do is that you can actually first second function as well. So you can try to find the second vulnerability as well. So in this video, we have seen what is the latest OpenSSL issues. There are actually two issues. We have also seen how can we replicate these issues using the built-in test cases from the fixed version to vulnerable version, and how can we use that. And we have also seen how can we use libfuzzer to find one of the issues. I hope that you have find this video useful. Please feel free to subscribe, like, and share my channel. Till the next video, stay safe and goodbye. Enjoy. Thank you. Bye.